Okay. So just now we have learnt about the diffusion. Now the second process, which is responsible for the absorption and the transportation of water in a plant, is imbibition also. Okay. So what is this imbibition? So we will start with this definition. Okay. So this imbibition is, if I define this, so it is a process of, let me, okay, you all cannot, yeah. You all can see the screen? Yes?
Yes, sir.
So this imbibition is what? It is the process of adsorption of water by the particles of a solid substance without forming a solution. So there is a difference between absorption and adsorption. Okay, so what is this absorption? In the absorption, so for example, if I explain you this term absorption, so it means, so suppose this is some kind of a cell. Okay, and if the solvent, so for example, if the water molecule is entering inside a cell and it is forming a kind of solution, then this type of water intake by a cell can be called as absorption. Okay, this type of what we can say, like water intake by a cell can be called as what? Absorption. Got it? And in case of the adsorption, what will happen? Suppose again this is a cell, or okay, suppose this is a cell, and suppose the water molecule, or what we can consider like this cell is having cell wall over here, which is not allowing the water to enter inside it. So the water molecule, if the water molecule is present on the surface of this solid surface, this structure, if the water molecule is present on its surface, then we can call this as what? The water molecule is adsorbed. Okay, so this is a difference between absorption and adsorption. Okay, so what happens in the imbibition? The water molecule is actually, it is adsorbed by a particle of a solid substance. So the particle could be a cell surface which is having some kind of impermeability, or it can be also a soil particle, it can be also a wood particles, wood piece. Okay, it can be anything. So anyone has any doubt regarding the definition of imbibition? Please let me know now. Then we can proceed with the second. Yes, everyone, no doubts? Yeah. Then we will move to the next, which is called as imbibent, or sometimes we can also call it as adsorbent. So the substance that imbibes the water, example, soil particle, wood, and resins. So again, if suppose these are the soil particles, and if the water is what we can say, like if the water is present on its surface, if the water is adsorbed on the surface of the solid particle, so this solid particle can be called as imbibent or adsorbent. Okay, and the water molecule which is adsorbed on the surface can be called as imbibate. Okay, so this is imbibate, and the solid which has adsorbed the water can be called as imbibent. Okay. Any doubts regarding the definition of the imbibition and the terminology which we have used regarding the imbibition. So first is adsorbent, second one is what? Imbibate. Any doubt? No?
No, sir.
Okay, just wait a second. Let me connect my laptop with the charger, then we will continue. Just a second. Yeah, welcome back. Okay. So just now we have discussed about this imbibient and adsorbent. Now we will see that what are the different characteristic of the imbibition, which is very important. So if you see the first characteristic, it is imbibition can be imbibition and adsorption. So the water molecules tightly held through the process of capillarity and gets immobilized. So here, if we understand the word capillarity, so you might have learned about some kinds of capillary action. Anyone knows about this? You might have learned in the physics when you have learned the topic surface tension. In that, you might have learned about the capillary action. So anyone knows about that? Okay, let me explain
No,
you.
sir.
Let me explain you in a very short that what is capillarity. So suppose I have taken again a beaker filled with the water. So suppose this is a beaker filled with the water. And if I insert a very fine tube inside this, then what do you think? The level of water inside the tube will remain the same, or will it increase or decrease? What do you think? Yes, anyone can tell me the answer. I think so. You all can try. Mohammed, Ashna, Zainab, you all can try that. What if I insert a capillary tube? Suppose I have, okay, let me demonstrate you. It's quite funny also. No? Yeah. Suppose this is a bottle of water and you can see I hope you can see the level of water is here. And if I insert a fine capillary tube, okay, then the level of water inside the tube will remain same, or it will increase or decrease. What will happen? What do you think? You can use your own intelligence. That is also fine. Yes. Ashna, Zainab, Muhammad, Manu.
Sir.
Yes. You all can try. That is fine. Okay. Anyone can try. No problem. If you remember, okay, the level of water inside, yeah, Upmanu?
Sir, I don't know.
Okay, let me explain you. So what will happen? The level of water inside the tube will slightly increase from the level of water in the beaker. And why it happens? The one reason is that if you see, the surface area of a beaker is quite larger as compared to the surface area of a fine capillary tube. Okay, so there will be slight difference in the temperature of the medium because area is
Sir,
okay, because we all know that surface area or the area is what we can say, like if the area is maximum, then the pressure will be low. Okay, so here the area is very low, so the pressure will be high. So due to the that change in the pressure, the water will be slightly pulled upward. Okay, and that is called as capillary action. I cannot say much more about than this about this capillary action because you will have a specific subtopic in your physics. So in that you will learn about this capillary action. But this capillary action plays a very, very important role in the upward movement of water in the plant also. Okay. So I hope just now you have some basic idea of the capillary action. So what it is, the water is slightly raised above or pulled upwards due to difference in the atmospheric pressure or due to difference in the pressure of a medium. You all are understanding? If no, then there's no problem. Okay. Like, but
sir,
yeah,
can you
for
explain
now,
once more?
yeah, I can explain you. Yeah. Let me use a whiteboard to explain. Yeah.
Sir, you can go to Microsoft Whiteboard or Notepad.
Okay. Okay. There is okay. Okay. Yeah. You all can see this Microsoft whiteboard.
Yes.
Yeah. So I have to. Yeah. Okay. Now you all can see? No? Okay.
No, sir, we
No,
cannot
sir.
see the whiteboard.
Previously, we are seeing it.
Now you can see?
Sir. We,
Yes?
no, sir, no, sir.
No, sir.
Okay.
Only letters only are
Microsoft
seeing.
whiteboard. Yes, now I can, yeah, now I can draw. Yeah.
Yes, sir. Now is it visible?
Yes, sir.
So let me explain you some basics of this capillary action. Okay. Where is the shape? Okay. Suppose this is again a kind of, no, I'm not able to, okay. Yeah. Let me take a shape. Yeah. So suppose the level of water in a beaker, let me use a different color. The level of water in a beaker is this. Okay. And the level of water in a capillary tube is slightly above. And this is reality. If you might have observed, so this happens. So there is a difference in the level of water always. So why there is a difference in the level of water? Because due to the difference in the pressure. Okay, so why there is a difference in the pressure? Because this beaker might be having some surface area. So suppose the surface area of beaker is capital A, then the surface area of this tube will be smaller because it is smaller in size. Okay, so the pressure in this beaker will be slightly lower because surface area is quite large. But in this capillary tube, the surface area is is low. So due to this, what will happen? The pressure will be quite relatively higher. Okay, so due to this, what will happen? The water molecule is pulled upward. The level of water is pulled upward. So this action or this process is called as capillarity. And this action is called as capillary action. And the best example of capillary action you all might have observed. So suppose this is a small deep, okay, filled with the oil. And if you keep a cotton plug over here, then this cotton plug will keep on burning, and this will adsorb oil from this deep diya. So how it happens? Simply, it is also happening due to the capillary action. Okay, so this is one example of capillary action. If you want to see one more example, just dip a dry piece of paper in a water, then you will see that the level of water is keep on increasing. You all have seen this or not? If you suppose this is a beaker, and if you just dip a dry piece of paper on the surface of water and keep observing, then you will see that the water level is keep on increasing. Yes or no? How many of you have observed this? Anyone has observed this? No?
It happens only with paper or any object put in water.
It can happen with any object which can or which has, this is very good question, which has affinity to water. Like cotton has a good affinity with water, so cotton can absorb. Paper has good affinity with water, then it can absorb. And if you find what is a common between paper and cotton, so both of these are made up of cellulose. So from this, what we can say, cellulose has a good affinity with the water. Okay, and that is the next point. Okay, that was our next point to be explained. So let me just explain you that point. So what was I trying to say? Let me just yeah, that is our next point. We will learn about that. So okay, now I hope you might have understood about the capillary action. Yes, then we will proceed ahead.
Sir.
Yeah. Next is what? The water molecule gets immobilized. Yeah, this is correct. For example, if this is a solid surface and if the water molecule gets attached on its surface, then definitely this water molecule cannot move ahead. So the water molecule gets immobilized. Like we know there is a word called as impossible, and the opposite word is called as possible. So in the same way, mobilize means what? Anything which is moving. But now the water molecule is trapped. So now it cannot move. So it is called as what? Immobilized. So after adsorption, water molecule gets immobilized. So due to which what happens? The volume of the imbibent will increase. Okay, simply you might have seen, like if you just pour this cotton in a water, then it will absorb water, then its volume will increase. Okay, so after the imbibition, what will happen? The volume of imbibent will increase, and this will create a tremendous amount of pressure. And this pressure is used in a different way. Okay, for example, if you know, in the ancient times, to break a large pieces of rock, okay, the people, they were using a small piece of wood. So suppose if this is a wood inserted in a large piece of rock, and they will just leave it. So once they will absorb water, then what will happen? Their volume will increase. So due to increase in the volume and creation of a tremendous amount of pressure, this rock were split into two different pieces. So this is how they were using the pressure generated by the imbibition. Okay, so these are the few characteristic of the what we can say imbibition. Next is conditions. This is very, very important. Conditions necessary for the imbibition. Okay, so what is first condition? The first condition is water potential gradient between the adsorbent substance and the liquid imbibe. Okay, so just now, if you remember, I have told you that diffusion pressure. Okay, this diffusion pressure is nowadays also called as water potential. Okay, I will tell you about this more about this when we learn osmosis. But for now, just remember that there should be some kind of gradient between the adsorbent surface and a liquid imbibe. Like what we can say, like there should be, like, suppose if this is a dry surface, suppose this is a dry surface and this is the water molecule. So imbibition will only takes place when this shows the gradient. Take one more example. Suppose this is the solid surface and it has already bounded with the water molecule. So the imbibition will not take place on this surface, but imbibition will take place on this surface because it has more affinity, it has more water gradient. Okay, so that is the meaning of first point. There should be a gradient between the adsorbent and the liquid which is imbibed. And the second point, which is very important, like affinity between adsorbent and the liquid. So for example, if you dip a plastic bottle inside a water, then that plastic will not absorb any amount of water. But if you put a piece of cotton, then definitely that will absorb water. So why there is such difference? It occurs due to the difference in the affinity. Okay, are you all getting? So this is very, very important. There should be affinity between adsorbent and the liquid. Got it? Yes. Anyone has any doubt till now? The definition of imbibition,
No
the
doubt.
characteristic. Now we will see just few what we can say, like importance of the imbibition. You might have seen also in your house, like imbibition is very, very important, or it is the initial step in the germination. Okay, so because we at least we all know that for the germination of for the germination of seed, water is needed. So why water is needed? Because water is first imbibed by a seed, then it will cause swelling of the seeds. That results in the breaking of the testa. Testa is what? It is the outer covering of the seed. So once the testa will break down, then only the radicals, the plumules will come out of the seeds. Just now, if you can see, so that imbibition helped to break out this testa. Okay, so that is why imbibition is very important during the germination. Okay, so these are very important points because they might ask you in the exam. The question might be something like this, like they might ask you that select the most appropriate or select the correct statement regarding the uses of or importance of imbibition during seed germination. So they might give you this kind of point. Okay, so considering that, please focus on this. What is the first step during the germination? Imbibition. Okay, second is what? Imbibition causes swelling of the seeds and resulting in the breaking of the testa. Just a second. Yeah. Okay, so imbibition causes swelling of the seeds. Yeah, and this is also this imbibition is also initial stage of water absorption by the roots. Okay, so I think so there was a question in the NEET exam. So that question was like what is the correct sequence of water absorption by the roots in a plant? So the options was diffusion, imbibition, then osmosis, or something like that. So what is first initial stage of the water absorption? It is imbibition. Okay, after that imbibition, diffusion will take place and osmosis will take place later. Okay, later on it. So, and yeah, one more point is given. The water moves into the ovule, which are ripening into the seeds by the imbibition. Again, so these are the few importance of the imbibition. But what you have to remember, it causes swelling of the seeds, and it is the initial stage of water absorption by the roots. Okay, so that is how we have completed the imbibition part also. So Upanyu, Muhammad, Zainab, Ashna, anyone has any doubt till
No, sir.
now?
No, sir, no doubts.
Okay, that's great. Yeah. So just now we have completed diffusion also, imbibition also. Now we can move to the next, which is very, very important, osmosis. How many of you remember the definition of osmosis? Then we can move ahead. Anyone remember the definition of osmosis?
Yes, sir.
Tell me. Like if you are comfortable, then you can turn on camera, na? Like if you are comfortable. Okay, okay, tell me. Definition of osmosis. Yes. If you want.
Movement of water from its higher chemical potential to its lower chemical potential.
Wow, perfect. The movement of water from its higher chemical potential to its lower chemical potential. Yeah, that is correct. Yeah, but I will improve this definition. Then what is that chemical potential? Yes. What is that chemical potential? Anyone who dares to answer?
Sir, chemical potential is the capacity of a liquid to hold a
Yes, yes, yes. You are quite correct.
uh,
The capacity of,
that ion or
yes, correct. So you
the
are very close
concentration
to
of the ion, sir,
the
actually.
constant. Okay, so you are quite correct. So let me explain you the funda of that chemical potential, or rather, if I use a correct word, so that is called as water potential. So first of all, let me again, I have to draw a diagram. So suppose I have taken a beaker, a long beaker, and let me draw. And suppose these are the water molecules. Again, I have to take a water molecule. Yeah. Okay. Okay. Yeah. And this is the, like, suppose this container or this system contains pure water. This system contains pure water. Okay, so there is no solute. It is completely pure solvent. Or okay. So now as per the I think so in your physics there is one law which is called as ideal gas law. Anyone remembers ideal gas law? No? Okay. So according to that law, what that law says that the gas molecules moves in a random manner. Okay, they are continuously keep moving in a random direction. So the almost same thing applies here. The water molecules, okay, listen carefully. This is very important to understand the water potential concept. So the water molecule will keep on moving in a random direction. Why it will keep on moving in a random direction? Because all the water molecules are what? They are free. And sometimes they will also collide with each other. And we also know, according to the ideal gas law, and that law is also applicable in this liquid. So we can say that each collision is a perfectly elastic. Okay. So after the collision, it will change its direction. That is also fine. But what is main point over here? Like all the water molecules will keep on moving in the random direction. Okay. So all the molecules will keep moving in randomly. Random direction. Why? Because all molecules are free. All water molecules are free. So its potential to dissolve any solute is higher. Yes or no? Please tell me yes if you are understanding this concept, or if no, then I can repeat this again. You all are getting this point, what I'm trying to explain?
Yes, sir.
Okay. So if you see over here, like all the water molecules are keep moving randomly and all of them are completely free. So if I dissolve, okay, before that, like I will explain one more point. So now I can say water has a maximum potential to dissolve any solute in it. Yes. So this is called as water potential. Okay, water potential is the tendency of water molecule. Okay, let me just write it over here. Water potential it is indicated as psi. This is a Greek word. Okay, is tendency of water to dissolve any solutes in it. So this is one definition of water potential. So if there are no solutes, in this beaker, then its water potential will be maximum. Yes or no? Yes. If there are no solutes present in this beaker, if this beaker contains pure water, then the water potential will be maximum. Are you agree with this point? Please reply me yes or no, then I can like proceed ahead. Yes.
Yes, sir.
Okay. So just now we have
Yes, sir.
seen. Okay. So if there are no solutes, then its water potential will be higher. And the water potential of a pure water is considered as 0. Please remember this. I hope you might have learned in your college also, or during your regular lectures also. Okay. Water potential of a pure water is 0. Okay. And if I add any solute, suppose I have added sugar molecule in this, something like this. Now, what will happen? This sugar molecule will be surrounded by the water molecule. Something like this. It will form a bond. I think so, ionic bond is formed. Okay, so now what will happen? The number of free water molecule will increase. Tell me now the number of free water molecules will increase or decrease? Yes. Tell me now the number of free water molecules will increase or decrease? Anyone can tell me? Again, I think so. I do not have to pronounce your names. Okay, anyone can tell me, like, if I dissolve solute in a pure water, then the number of free water molecules will increase or decrease?
Decrease.
Exactly. Why it will decrease? Because now
Sir,
the
it will
solutes
form a heterogeneous mixture with others or
and
homogeneous.
And if you see that these molecules, these water molecules, or we can call it as solvent molecule, it is bounded with this solute. So the number of free water molecule is decreasing. So if the number of free water molecule is decreased, it means the water potential will also decrease. Okay, let me give you one statement to understand so it is something like this. Water potential, okay, water potential which is indicated as a Greek letter psi. Okay, it is written as psi, this word. Okay, so water potential is directly proportional to the number of free solvent molecule. Please remember this number of free in case of this free water molecule, because we are talking about the water potential. So number of free water molecule. Please note down this. This is very important points to understand about the water potential. So if we dissolve any solutes, the number of water molecule will decrease. Number of free water molecule will decrease. So what does it mean? The water potential will also decrease. Yes or no? Got it? If you have understood this, then it would be very easy for you to understand the process of osmosis, that why it happens and how it happens. So just tell me, how many of you have understood about the concept of water potential? You all? Yes? Ashna, Muhammad, Upanyu, you all have understood about the water potential?
Yes, sir.
Yes, sir.
So again, less than 1 minute is left. Okay, so we will join back. Then we will see that how osmosis happens. Okay, got it? I think so. Still, we have 10 minutes to go now. So you have another lecture from 7.
No, sir.
Okay, so can we like extend till 7:05?
Okay, sir.
Okay, yeah. Please join back.